stuck with like 2 minutes to go. I don't understand what is happening here. I cannot get the slides window to show up as the slides. I don't know what's going on. It's got some weird, I mean, it looks like I need to restart X, or maybe, you know, like reboot the whole thing. It says it claims it's got a window, but let's, you see, it ain't there. And it's supposed to be, I don't know what it's supposed to be. It's supposed to be new RHD. I guess it is new RHD. Oh, that's locked. Yeah, it's new RHD. All right. Well, so I don't know how we're gonna play this. Could I put a filter on it and just try to crop around it? This is great. Well, maybe we'll start a little late. 200, 200. What a mess. All right, I'm just going to go ahead. I'm not going to call this the start. I'm going to keep fucking around with this in the true spirit of, like, when it used to be getting projectors, getting digital projectors to talk to your laptop, like that. I am going to, oh, of course, we're supposed to, oh yeah, this is going to be just super jolly, because we're going to see all the, oh no, well, screw it, so be it, so it shall be, and I wish these were, I mean, they look like they're, but they're not. All right, maybe we'll go at like 12:05. How about that? So if any people are here watching, well then, oops, filters, oh, could I adjust this by hand? No. But I could pull it this way. Oh, this is going to be a terrible, terrible drag. I tried to display it in a different window, but I really think I need to, I don't know, I hate to say in Linux land, I hate to say I need to reboot, but geez, what a mess. I am gonna, let's see, I am going to continue cropping along here, and then I'm gonna try to, can I delete some of these slides all at once? Ooh, maybe I can. All right, well, that'll have to do. Great. Okay, so maybe we'll start at like 12:03 or 12:04, something like that. All right, and can I stretch this now? Maybe. Uh, 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 oh, this is going to be so horrible. I'm going to take one more try at starting the slideshow. Yeah, it's still screwed up. It's screwed up. What a drag. I'm going to try just one last try. Oh, man. All right, so we have to exit the fake presentation slide, which does not show. We're going to try putting it on all displays. And okay, except now I can't tell. Let's see. Oh, great. We got it to work on all displays. Okay. Well, I'm just going to keep on working. I'm sorry. I'm really sorry. Are any folks come around? Oh, look at all these people. What a disaster. Hey guys. No, where is it? There it is. You can see we're screwed up. I don't get it. I really don't get it. At least the mic is on. Thank goodness we get to cut around the all right, so yeah, I was gonna try displaying it on the teleprompter. Let's call that display 3, maybe. Oh, well, that looks like it kind of is where I wanted it. Like maybe it just, we shall see. Oh, that does not look quite right, but oh no, that does not look quite right. Oh, I must have extra things turned on. New RHD and slides window. Okay. All right. Now, if we resize this or turn off the padding and but it's still scaled all to hell. All right, we're actually making progress here. Guess what the title is? So somehow I think what happened is there was some kind of glitch in the matrix that caused the displays to get re-enumerated or something like that. And can we? All right. Okay. Maybe maybe I'm just gonna go ahead and call this close enough for now. Is that white line visible? I can't exactly tell. All right. Maybe it is. All right. Hey. Okay. Oh, boy. All right, let's now see, my clock is all messed up here. I thought it was only off by a few seconds, but it's actually off by a couple of minutes. All right. Let's go back to the waiting room. Okay. Start at 12. Hey folks, it's T2sday. This is the T2 tile project where we are trying to build a whole new computational stack from the bottom up, a whole new stack, trying to get around some of the problems that have been along with computing, along with all the amazingness of computing since the beginning. And so today is a big day for me. We've been working on a new kind of architecture for a long time. This is a project that has been going since, I believe, summer of 24, at least as far as thinking about it, and some delayed gratification big time here. So I don't know how long this is going to take, but it's going to take a while. Okay, so this was the goal for today. Live noon Mountain Time. I failed in that goal. It's now 10 past or something like it, and I have to blow my nose. We'll see if I can get through. It's okay. The goals we hear, and here are the results. Toddler P4 events, yes. What's that? We'll find out. Visible FB Dragon Res, what's that? Etc. Check off many to-dos. Well, you can see what that is. Yes. Have much more huge fun. Yes. Yay. Prepare for NaNoWriMo. No, didn't even try. So FB, that's not Facebook, that's Forkbomb. Dreg and Res are some of the classic laws of physics of this new computational model that I've been exploring. Okay, I'm going to actually try to blow my nose for a second, excuse me. All right, can we still hear each other? Can we still hear me? Okay. Oh, sorry for the people in the cans. All right, so this is how we did. And just jumping right into it, black holes are hot. We're building architecture for this thing called a black hole quiet box. It comes from a company called TenseTorrent. The Living Computation Foundation got a wonderful donation of money to buy this thing. It's not cheap, and it is indeed hot. I talked about it last time. However, I can tell by the clock on the kitchen wall that it's autumn o'clock, and things are starting to get different. So the heat that was coming off of the quiet box that was just baking me in this room here, which meant I had to run air conditioning pretty much continuously just to offset it. And I built a box to suck more of the heat out in the last episode. Well, now, like the rest of the house is like a lot colder than this was. So I took the box, and I trundled it out into the hallway, which is not heated at the moment. I mean, in the Southwest, you got to decide in the spring when to turn on the swamp cooler to start, do the air conditioning. And in the winter, you need to know when to shut the swamp cooler off and start the furnace or the wood burning stove, whatever you got. We haven't started the furnace yet here, but we haven't needed to, because we have the quiet box sitting in the hall, radiating heat. This bag here is cat discouragement to keep them from sleeping on top of the thing, and also to keep all the hair and so forth from getting in there. If you look way down here, there's a big heavy-duty extension cord coming through there, and then 2 Ethernet cables going back in. And this is what I've been running on. This is what we'll be running on in a few minutes. So, the road to today. I'm going to rush through this because I don't know exactly how much time I've taken and so forth, but since we last talked, oh yeah, so the black hole quiet box, which could really be called a hot box, is now performing the task of heating this place for the moment, and we'll see how it goes, and we'll see how the electric company feels about it when I get the bill. So, 27 days ago, right after the previous update, this was going to be a short interval, 28 days to today, so I wanted to jump right on it. I wanted to build a curses interface. A curses interface is where you just have a terminal and you have text stuff and you have stuff bouncing around just using ASCII graphics on the screen. It looks like 1970s on a mainframe. But all it requires is the ability to have a terminal. I've written many programs using curses. It's a library in C over the decades, but now I did some Googling, or actually I did some Kagiing, and I discovered Textual, which is an all-singing, all-dancing Python package, hundreds of thousands of lines of code. It's huge, that does curses interfaces like on steroids. And I discovered PyBind11, another package which allows you to take C++ code and put it together with Python code. It's used by lots of big projects. So 25 days ago, I had written a few tiny little textual and PyBind11 spikes, a few little tiny demos, and I'd gotten them working because, it's easy to get them working if you just follow the tutorial. It's when you want to step off and do your own stuff that things starts getting bad. PyBind11 is expecting to use, it's most happy or comfortable using this build system called CMake, which I had never used before. I'd used Make, which is decades old and not really maintained that much. Well, it's still maintained, but CMake is much newer. And so I got down with the AI and we vibe coded a CMake framework to get it working. And between Friday and Saturday and a lot of chatting back and forth with the AI, got a framework that seemed to work, that had textual, it had C++ code, it had PyBind11 connecting them together, and it was pretty amazing. It really was. It made bunches of mistakes, but by the end of it, I was like, holy moly, everything works. I now have an entirely new CMake build system. I don't know how to react to these things. On the one hand, it's just a statistical parser. It's just a stupid little, mathematical engine. But on the other hand, I have every reason to believe that every conversation anybody on the planet has with one of these large language models is being captured and used to train a new generation of large language models. So, if we're just act like a dick to it, maybe it's going to learn to be a dick back. So I don't know. So I was actually kind of trying to be polite, and in fact the AI just came back with, "Oh, that's fantastic! I'm thrilled." It was a complex journey, many subtle CMake, but we tackled each one. Enjoy your new fully functional build setup, which sounds to me like enjoy your fully operational Death Star, but I have to admit, I wouldn't have even tried to do this. It would have been too aggravating without something to handhold. So 23 days ago, I started importing my own code, MFMX, the movable feast machine. That's the overall architecture that the T2 Tile project has been exploring for decades. Well, the T2 Tile project has been exploring since 2018. I've been exploring for decades. And I'm building a version of it that meant to run on the quiet box, and I started importing it so that you could run things from Python and say, black hole, and build a new thing and say blackhole.start and so on and so forth. On October 13th, I tried to start building attempts and put them all together. So that's where I'm stepping off the convenient path of the tutorials. And T-minus 19 days, it was just bug after bug after bug after bug. There was one that took me, I think, over a day, where, the host block is something I made up. And it's this little data structure that the host in the center, the x86 standard computer that's in the quiet box, sends a copy of this host block to every Tenzix tile out in the world that's involved in this project. Well, not in the world, elsewhere in the quiet box. And I was just trying to read that back from the Tenzix tiles and make sure that it had gotten there properly, and everything was reading as 0. And I couldn't figure out why. I tried everything, and it turned out this unbelievable thing, that there's a function called memset, memory set. Its job is to set the contents of memory to a certain value. What value? The value that you give for the second argument. So you say 0, you set it to 0. It's supposed to set memory to 0. Well, it turns out the compiler has its own idea about things, and in certain cases it says, geez, I can tell that the code that they're setting, this block of memory that they're setting to 0, is never going to be referenced, so I don't even have to do it. I don't have to set it to 0. And that means that when it was going on and using it later, it wasn't initialized. And yeah, I'm sure, technically, according to the language, I was doing something wrong, but the code I was writing was pretty damn obvious looking, and I had to, it was a drag. But that's all it was. But then that was easy. 17 days ago, under 3 weeks, I was fighting with threading bugs. That, textual has a user interface, and you want that to stay all clicky so that people can click on it. But in the background, you need to be doing all this stuff with the black holes. So you need these multiple threads. And threads are the kryptonite of traditional computing. Traditional computing is single-threaded. Do one thing at a time. Everybody waits till you're done. But that's not good enough for a lot of computations that we want to do today, so they invented multi-threading. And this is nothing new, but getting multi-threading to work, so because they're all messing in the same puddle of memory, and one can easily stomp on what another one is thinking hasn't been stomped on. I spent 4 days on it. Wednesday at T-minus 13, under 2 weeks now, I said, I just started over, and I was right back in thread hell. Days after days. And, it gotten to the point that I couldn't really go back to the AI, not easily, because I had too much customization. It would have to start all over again. And I did start all over again a couple times, and it wasn't quite as helpful. 10 days ago, a week and a half ago, October 25th, I fixed the threading bugs, and I'm not entirely sure how. I have some ideas, but it is a very unsatisfying story about a bug. But even with that, we were only 10 days out, and there was a tremendous amount of stuff still unimplemented. So I jumped right back into it, and I immediately got into C++ template hell, a similar thing. It's not as bad as threads, but I had this, over-ambitious, like I always do, idea that, some code needs to run on the Tenzix tiles, the T6s. Some code needs to run on the host, and some code needs to run on both. In particular, these packets that are getting sent back and forth, communications about various purposes, they need to be run on both sides. So I thought, I'll make a shared directory, and this was part of what the AI helped me set up way back in the beginning, where it was C-mix nuances that we solved, and we did. I put a bunch of code in the shared directory, and it was all these templates. So it was supposed to be able to go one way for the host and go another way for the Tenzix tiles, and it was a mess, and I didn't know what I was doing, and it had blocked me from progressing on the shared side a lot. And so eventually, in a whole new class of bugs, word versus byte count bugs, I had a lot of that wasted a lot of time. I mean, I'm just being honest, but geez. So eventually, a week ago today, I ditched most of the shared code templates. And my mantra is share only data. If you're exchanging data between two sides, well, you have to exchange the description of the data. And, in the modern era, we just use some interchange format like JSON or whatever it is, and then as long as both sides parse JSON properly or improperly in the same way, everything works. But this, between the host and the 10.6 tiles, is meant to go fast, and so it's very low level and it's very specific. This helped a ton. It meant there was some duplicated code on the host side and the 10.6 tile, but it meant I could evolve them separately without having to wonder about the significantly different issues that the heart stands for hardware thread on the T6 tiles versus on the host. And 6 days ago, I finally had a demo of sending a packet. I call them cars because the model I'm using is elevators. This is like two-stop elevators, which is not a really good example of an elevator, but they have cars that are open and you fill them up and then the cars close and they go to the other end and they open up and you empty them out and they close and they go back and forth. And I had the first round trip of multiple cars between the host and the 10.6 tile. And, you know, this was, well, 2 months coming, or at least a month and a half, where I was actually working on the code, which finally did this 6 days ago. 5 days ago, I tried to hook it up more deeply with textual on the Python side instead of just doing little standalone test scripts, and I was instantly into a whole new thread hell called Python GIL thread hell. GIL stands for Global Interpreter Lock, and it's a disaster. And again, it's a disaster on top of a disaster because threads are already a disaster. That was terrible. But now I was having to debug C++ code, well, more than Python code, except for the fact that Python code was helping out with causing the deadlocks and the seg faults. But eventually I started working not just on log cars, going back. Logs were exchanging log information, status information printouts so that I could tell what's happening on the T6s. You cannot look at the T6s. They don't have a monitor because they're too small. There's too many of them. And 4 days ago, whoops, are we right here? Yeah, 4 days ago, I actually scheduled this talk, which is now running late. Saturday, it was like, the quiet box is just too hot. EW control, event window control, I exposed it in Python so we could start doing things like make an event window, select a copy of atoms from somewhere on the grid. That's an event window that we could send off to a T6 to work on. 2 days ago on Sunday, moved the quiet box out in the hall. I showed you the picture. Actually got an EWD10, a Python script that drove trying to do events going back and forth. Yet another incredibly stupid bug, one after another. It's amazing how many stupid bugs I can make. I don't know. Well, I feel like it's more than I made when I was younger, but I really can't tell. 36 hours ago, I got far enough that I actually needed to have some physics, some rules, not for C++, not for textual, not for Python, but for the cellular automata that we're going to be simulating on this T6 tile or in this quiet box in general. And so getting as far as needing MFM physics was a big breakthrough. 25 hours ago, Heartbee. So again, I'll show the map of all this. Heartbee is one of the smallest little things inside a 10.6 tile. Inside each 10.6 tile, there are 5 hearts. Heart stands for hardware thread, and Heartbee is one of the 5, and that's the one that I've tapped to actually do the event window processing, at least so far. And it ran it for the first time and sent the answer back, and I could see it. Yay! Well, no. It only did 3 events, and then it locked up. And, 22 hours ago, I figured it out. And got the round trip going reliably. So the host had a big array inside its own memory where it picks out event windows, sends them off to a T6 tile. Whoever has got whatever elevator cars, whatever empty elevator cars are on the host, it fills them with event windows and sends them out to all the specific T6 tiles on the black holes. Each of those gets it, processes it, comes up with a new state, sends it back to the host, and the host merges it into the grid. And there's a tremendous question about how do you make sure that the events come in the right order and you don't get halfway through one event and stomp it with another event and so on. And I've taken an incredibly lame attitude to it, where it just tries to apply it, and it excludes everybody else from accessing the memory just at the time it's trying to apply this one window. And then once it's got it, it says, okay, is the event window currently where it's supposed to be the same as it was when I sent this event out? And if it is, then I replace it with the new window that the T6 tile sent back. And if it's not, I just throw it on the floor. So I have, instead of having locking problems, which I had plenty of locking problems, but instead of event window locking problems, I have acceptance ratio problems, where a significant fraction, a huge fraction at the moment, of the event windows that I send out, by the time they come back, they've either already been done or something else has been done, which means that their input is no longer valid, so we can't apply them and we have to throw them away. But it worked, and that was great. I absolutely enjoyed it. So, in the last couple of hours, in addition to trying to get ready to do our T2sday update that we're doing now, I got Fork Bomb running, and there were 5% acceptance rate. Is this horrible AI waste of energy thinking, or what? 95% of the event windows that we send out to the T6 tiles, they come back and they get dumped because they've already been done. Now, a large part of the reason for that is that Fork Bomb just fills space, and once it's filled space, there's nothing left to do on the inside. Another physics, drag and res, has particles that bounce around, and we'll see that in a second. So there's more variety going on, and there's more different events that can be sent out to the T6 tiles. And since then, I've been trying to get ready for the update and just feeling pretty good. Oh, I have a new button. Feeling pretty good. Yeah. All right. So that's the toddler events. Can we demo it? Can we actually demo it? Maybe. I'm gonna pretend. Well, I'm gonna try it, and we'll see. This is what the actual code looks like, and this is C++ code to do Fork Bomb or to do drag, and it's very, very low level, but it's working, and we're going to need to improve on that as we go along. So the first thing I'm going to do is recompile. All right, so it's already finished recompiling the code that's going to go onto the T6s. Now it's rebuilding the code that's going to run on the host, and most of the time is wasted getting these dependencies of Python. And all right, and there it is. Now it's actually done. And okay, so now I'm going to run it. All right, let's, probably can't see this here, but in a second. Okay. So there it is. This is drag and res running on a grid that's getting bigger as we go. And you probably could have seen it for a while, but you can't see it now. That 2 is the drag and 3 is the res. And they're just bouncing around and so on and so forth. So in the interest of saving time, all right, I'm going to stop this one, and I'm going to go ahead and do the Fork Bomb just because it's more fun, or it's more fun to watch anyway. Look at that go. Now, I'm only displaying so many rows. This is not fast by the standards of what you could do with a GPU on Fork Bomb, but it's a beginning. And so, okay. So hopefully that was visible. I don't know how it works so far. This is I've gone way too long. I'm going to skip this. I'll come back to this and talk about it in the live stream. So I'll put a link to it, so if folks are watching the T2sday update and they want to see a little bit more internal stuff, they can go to the live stream. I'll skip this also and just run to the plans for next time. So this is the last T2sday update in 2025. I'm taking the month of November off officially to write not C++, not Python, but English, to try to do writing, to try to write scripts for videos, put up a video on the Dave Ackley channel. Maybe that would be great. Try to get this collected works of living computation that I've been working on for a couple of years. Try to get that much closer to ready to ship, and so on. So that's what it's really about. And you know, if you encounter me out on the social networks in November, please ask me, why aren't you writing? And I will appreciate it, even if it doesn't seem like I do. And in addition, clean up the code base, and I'd like to get some kind of actual graphical output working as well before January 6th when we come back again. So that is it. Thank you so much for stopping by, everybody that's come and seen it live or come and seeing it later, or any combination of the both. Have a happy New Year, Merry Christmas, Happy Thanksgiving, all these whatever holidays you subscribe to. And I haven't completely given up hope that the world could start sucking less, all evidence aside, but we shall see. Hope to see you in January next year. All righty. So did the chat business work at all? It doesn't seem like it is. Chat and me. Maybe we'll get rid of. Uh-oh. This seems like a huge disaster. Well, I can't tell what's going on here. I can't tell if we're seeing anything. Why am I not seeing the waiting room? All right, it looks like I must have. Oh, we still got the display going. Okay, is that it? Now can I see it? No, we cannot. Tell you what. Suppose we just go here. Hi, folks. Can you see me at all? If we go to, I don't know what the heck happened to, it's still there. All right, I think it must. Let's pretend it's working. Can someone confirm? What happened? All right, I'm putting this over here. I am. So we're still live. So wait a minute. Any of the updated oh no, nothing? Oh, what did this say? Oh, okay. All right, great. So something is busted now, but we don't know why it is. Okay, thank you, Gert. I've got this flashing again on my right-hand window. Oh, and that looks like the camera's fucked up, is what it looks like. Oh, it is fucked up. Look at that. Usually I can reset it. Oh, okay. All right. Well, yes, Pun Master, I can still see your puns. Oh dear, what a disaster. Well, I don't care. I don't care that you can't hear me. I can't hear y'all. So I'm not gonna go over the extra stuff. Too bad. Well, maybe we'll talk about it. Maybe talk about it in the Discord or something. And I'm just gonna go ahead and try to shut this down and hope that it means we didn't lose our the recording. Okay, and it sounds like, looks like the microphone is still going. All right. Yeah, I understand. I think I'd have to restart OBS to get it back, which will screw with the stream. But what the heck? Maybe it's like we're kind of set anyway. So maybe I could try to restart OBS and see if I can get the camera back. And if not, it's not going to be that much worse than than we are right now. So I'm going to go ahead and stop the recording and then try to see if I can restart. And if not, I'll just end the stream. Now, theoretically, but the camera is still fucked, so that's really bad. No sonic boom. Well, thank you for that. Hey, okay. It looks like I'm working. Thank you, Wayne. And okay, all right. Well, then I'm gonna give up. And because my yeah. Well, thanks for the help and the feedback. I think yeah. I'll save up. What I really wanted to say about the current setup is that it is disgustingly centralized. All of the, thanks, David, all of the event windows are selected in the center. They're farmed out. The Tenzix tiles don't use any of the structure next to them. The fact that they're laid out in a 2D grid is irrelevant for purposes of this demo. And everything has to come back to the center in order to be merged. That was the simplest thing I could try to get working, and as you saw, it took a fair bit of effort for such as me to get that far. But now I have gotten that far, and it feels good. And there's a whole bunch of steps that I want to look towards going down the road to start decentralizing it again. And we'll talk about that as we go forward, rather than trying to deal with it in this crazy mess. I got to reboot this thing and figure out what's going on. So thanks, folks, especially for showing up live here. What a mess. And hope to see you all next year. Hope to see you on the Discord, the T2 Tile Discord. Yeah, in the meantime, thank you. Oh, I'm getting those little hundreds and things. Yeah, and I will, I'll shut it down now. I guess that's what we're saying. Oh no, I figured out what it was. Oh, I've done this before. Oh my God. Hello, I'm back. Oh. I figured out what it was. I didn't need to stop the broadcast. I didn't need to do any of this. Because it was just that I had faded out at the end of the T2sday update, and I always forget I have to end the fade. Yeah, hello. Here I am. Unclear. Oh dear. I blamed OBS for yet again my own stupidity. Oh well, but could have done worse. None of this is getting recorded except on YouTube. Usually I record everything all locally as well, but I had to stop the recording when I restarted OBS. Okay, well, do I actually dare after I messed everything up? Try. Right. So there it is. That's what I wanted to talk about. So at least I'll just mention this much. One of the things I want to try to do, because I realize all of these jargon words get tossed around, and of course I've been living with them for months, and sometimes I find that people out in the world have felt off-put or even guilty that they didn't recognize some of this jargon, and and I feel terrible about that. So I made this diagram, and so the first one is, so this white box here, that is the quiet box. Everything that's inside this box now is physically located in the quiet box that currently has a net over it and is heating up the house. So when I say host, that is a standard, well, it's a high-end, I don't know, 16, I don't even know how many cores it has. It's a AMD Epic something or other server with a lot of cores and a lot of memory. I don't remember how much memory. I haven't run into a problem yet. I mean, one of the things about the quiet box being expensive is that they blow out the specs pretty good, and so you don't have to say, oh, should I get 36 gigabytes or should I get 32 gigabytes or should I get 64 megabytes or what? They've already sprung for lots of everything. Then Black Hole 0, Black Hole 1, Black Hole 2, and Black Hole 3, those are physical cards, each individual one. So there's 4 Black Hole cards that are plugged into PCIe slots. And once again, it doesn't matter what those are, but people who are PC nerds will know about those slots and the ×4 and ×16 and so forth. All of that is inside the quiet box. But we're not done. So if you take one of these black hole cards and zoom in on it, that's where you find the T6 tiles, the Tenzix tiles. And they're arranged in a 2D grid, something like 16 by 12 or whatever it is. If you multiply it out, you get 140. So on each black hole card, there's 140 Tenzix tiles. And in my case, they have some black hole cards that have some rows knocked out because of manufacturing defects, so they may only have like 120 T6 tiles, something like that. But once again, the quiet box black hole has all the premium stuff. And so all the time talking about Tenzix or T6 tiles, that's referring to these 140 inside one black hole. There's another 140 here, another 140, another 140 in each of the black hole cards. But that's not the end either. Inside each Tenzix tile, there are 5 hearts. Hardware threads, H-A-R-T. And that's not a Tenzix jargon. That's not a Tens Torrent jargon. That's a RISC-V jargon, the terminology of the instruction set that these little teeny computers all run. It's called RISC-V. Inside each T6, there are 5 hearts that have weird labeling. There's B, T0, T1, T2, and NC. And the names reflect what the Tens Torrent folks sort of expected you to do with them. I am abusing them completely according to the name. And unfortunately, the easy way to number the hearts is 0, 1, 2, 3, 4. But that means that heart B is 0 and heart T0 is 1, and T1 is 2, and T2 is 3. And one of the incredibly stupid bugs that I fixed 30 hours ago, maybe less than 24 hours ago, I don't even know now, was because I was completely misinterpreting. I was printing out the heart number, and it was printing out 2, and I was saying, what's wrong with T2? Nothing's wrong with T2. T2 is fine. And I looked and looked and looked at it, and I realized that was the index. That wasn't the heart name. The index 2 corresponds to heart T1. I'd been looking in the wrong place the whole time. His staff is too short. He's digging in the wrong place. Man. And these 5 hearts in each T6 tile are united by the fact that they share 1 megabyte of RAM. And they have little bits of memory, of private memory, and so on and so forth. Each of those hearts sharing that 1 megabyte of RAM runs at somewhere between 800 megahertz and 1.3 gigahertz. They can actually run as low as 200 megahertz, so people say on the Discord. I haven't demonstrated it myself. And that's part of why they're so hot. So at the moment, and this is finally it, all the demos that we just saw are running using just 1 black hole card. Actually, I think it's 3. I don't know. I kept changing around to make sure it didn't matter. And so it's using just 1 card, using just 140 T6 tiles, and it's all running at 800 megahertz. So, so the good news is we have, 4 times the number of tiles. We have 3 more sets of 140 T6 tiles that we can bring into the mix as we go down the road. And we can jack them up from 800 megahertz, which is what we saw, to 1.3 gigahertz and see how it goes. So there's a lot of hardware room for speed up over what we saw in the very, very first demo, the first event windows on the T6s. But I'm looking for much more out of the software redesign and so forth as we get more experience in working down. And then finally, as I started to say, this whole design is bogus, because the whole point of the T2 tile project was indefinite scalability, the ability to grow as large as you can just by adding more tiles. Buy more tiles, plug them in, the whole thing uses them. We can't do that on the black hole. We can do it kind of. I mean, we can scale from 1T6 to 140, and we can scale from 140 to 4 times 140. And some people have been working using those crazy 800 megabits a second, 800 gigabits a second. I can't even say the right unit. Those things are so fast. Really 400 gigabits per second, but that's still, oh my God. To connect up not just between the black holes on a single quiet box, but between black holes on multiple quiet boxes and so forth. So TensTorrent tells a story about it being indefinitely scalable, and their earlier model of architecture called Wormhole, which I was starting out studying, but then Black Hole was more attractive, so that's the one I bought. Wormhole has a more laid out scaling story. It's still not indefinitely scalable in the strict sense that we use it in the movable feast machine architecture and in the T2 tile project. But that's not our goal here. Our goal here is to run significant, substantial models like the reproducing diamonds that we see in the waiting room at the beginning of each T2sday live stream at much faster speeds than we have been able to run them on the T2 tile. And the T2 tile matrix that I have in the other room, which is currently turned off so that it's not fighting for more electrical power with the quiet box, is not fast. The data that we see in the waiting room stuff is like from a month of runtime. I would like to get that down closer to a week or a day to do all of that. That may be asking too much, but to do a little snip of it in an hour so that you could actually look at it and see things changing, which when you went up to the T-tile matrix, you could see things changing, but you had to look close. It's not like it was catching the peripheral vision of action going on all over the place. So that's the hope, and that's the trade-off. That's the deal with the devil that I agreed to make, to try to make a more compelling set of demos that people could maybe interact with live, more or less, in some fashion down the road. And in order to do that, inevitably, I'm accepting centralization, which I want to reject in the long run. And I want to say that the Quiet Box Black Hole Simulator is not an indefinitely scalable architecture. It is a simulator of a finite chunk of a movable feast machine grid. And if the real issues, the real challenges of dealing with larger than the Quiet Box is going to be able to handle, go see the T2 tiles and let's see if we could do something more like that. So that's what I was really meaning to say. Okay, and unless there's questions, hey, look at that. Once we get back to I'll just tell you one little extra secret that I didn't mention, and it's not a secret, but in addition, on each black hole card, so now we know what that is, black hole smaller than a quiet box, bigger than a T6, on each black hole card, in addition to the 140 T6 tiles, there are 4 CPUs. They're not super fast CPUs, but they're full-fledged 4-core CPUs. There's 4 4-core CPUs on the black hole chip as well, and they have demonstrated running Linux on those 4-core multiprocessors. And so what I want to do is take the current centralization, which brings everything through the black hole cards into the host, and instead get Linux running on one or more of those little CPU clusters inside each black hole card, and have it coordinate the event feeds with the 140 Tensix tiles in its fleet that are under it, and have the actual host just deal with merging frames coming in from the black hole cards. So if we get to that, that would be big fun again. But that's going to be a lot of work too. Again. So all right. So that's it. So we got it all back. And thank you, yay, thank you for the hearts. And now once again, happy holidays, happy New Year. Let's hope for liberty and justice for all in the new year. Wayne, could you distribute code over different cards? Yes. Well, I mean, the existing code base will already take a single program, like the one that has a combination of fork bomb and dreg physics, and it can distribute that code over all 4 black hole cards. I mean, they do it separately. The host has to say, here, you get the code, you get the code, you get the code, everybody gets the code, like that. And I absolutely could. I mean, it would just be a matter of reprogramming at the host to take in, like, 4 path names and send 4 different files, one to each black hole card, and they would then be running 4 different codes if we had some purpose for that. I mean, if we wanted to do, experiments where 140 tiles was enough, we could do 4 independent experiments, one on each black hole tile, for example. But the real go is to have all 4 black hole cards with all 4. So 100 is 400, 560. Is that right? 4 times 140. 400 plus 160, 560, all 560 T6 tiles working together on the same physics, all merging together into a single cellular automata grid of enough size that we can see some big structures moving and changing. That's what we shall see. All right, thank you for the question. I didn't really go back and see if there was anything. Where did it go? Okay, I know where it went. Okay, looks like taking time off to write Nazi. To write not C++. I see what you did there. And okay, there we are. White line. Oh, great. Make works great. Wayne, yeah. So I didn't even really understand this when I first started doing it, but yeah, so this all singing, all dancing CMake on Unix, on Linux, it compiles makefiles. It compiles into makefiles. So CMake is actually a wrapper around make, at least on Linux. And so there's still make under the hood, but there's a buttload of make under the hood. I took a look at some of the generated files and said, yeah, I don't want to understand this. I really don't want to understand this. And it does do nice things. It does, better stuff as far as dependency tracking. And it does a lot of stuff well as interfacing to Python packages and so forth. Does it need some kind of synchronization to get a higher acceptance rate? Yeah. I mean, the way the one person I know who has built an MFM model on GPUs on NVIDIA does a trick that is similar, except they do it in parallel, where you select where all the event windows are going to be on the whole grid as a coordinated phase, and you arrange at that point so that none of the event windows are overlapping. And so that takes some time, and it takes some effective negotiation, and there's a trick so that you can do it so it's pretty parallel, and you end up with, like I said, non-overlapping event windows, and then you can then fire them off to the GPU cores and get results back which you're guaranteed to accept, because you know up front by construction that there won't be any overlaps. The trade-off is that the GPUs really struggle to deal with multiple elements, to deal with, you know, if it's only one element, like a fork bomb, so then that means all of the event windows that are going on out there are all running the same fork bomb code, and they can do it in lockstep, just like GPUs are built to do. But we can have all these, like dreg and res that we just saw. The dreg code is different than the res code. They have different behaviors, and as a result, we would rather not be running dreg code on the entire fleet and telling all the res guy, you just wait, and then running res code on the entire fleet and telling the everybody else to just wait. And that's pretty much what you have to do if you're trying to do it on a GPU, a traditional SIMD GPU. You have to enumerate through all of the code of all of the types and have everybody just duck their heads until the code that corresponds to their type comes down through the pipeline from God. And so that's what was unacceptable to me. That's what pushed me onto the road that has led to Tens Torrent and the black holes. So yeah, there's going to be some kind of synchronization. We'll see, but I want to come at it very gently, very slowly, rather than coming at it from the SIMD. We're lockstep all the way to the individual instruction, and then we go up from there. So we'll see how far we get. Again, this is the stupidest, most minimal, centralized everything that I could imagine to start going with, and I am thrilled. I am thrilled. That actually seems to be working. Fantastic project that goes strong. Thank you, Punmaster. All right, so video, yeah, all these bugs. Distribute the code. Okay, and then back to Wayne. All right, so that's it. Thank you, guys. I'm guessing it's mostly guys. I don't actually know that 100% for sure. Thanks so much for being here live so that we could chat. And that's it. I'm gonna call it now. All right. I am going to end the broadcast. Can I do end broadcast? I think maybe I can do end broadcast.